Welcome back. I'm charging my camcorder a bit and it's super hot. It's now like 30 degrees. It's close to 30 and it will go 31, 32 and it's not even 11. It's close to 11 AM. I like to finish this. Then I will go to bed and waiting for the sun go down. I was out shopping some milk and yogurt. Got some big meatballs, tomatoes, cooked potato salad. Got meatballs in rice and curry. But we'll not eat now because it's not even 11. Eat later tonight. So just drink a lot of water and some salty sticks I'll eat later. So let's finish reading. Then I will make a video in my language, Danish. After this, it was supposed to be English, but I cannot do that now because my life is stupid. Every day my life is stupid, and debt is only
And 55mm 52 caliber ordnance has a maximum range of 40,000 plus M. The 155mm 52 caliber ordnance and recoil system is of the company's well-proven type already used in its towed weapons. The breech block assembly is of the semi-automatic wedge type that contains an automatic primer feeding system that enables manual reloading of the primer without opening the breech. Turret traverse and weapon elevation is hydraulic, with manual controls for emergency use. A maximum rate of fire of 9 rounds /min can be achieved due to the automatic computerized loading system, and a burst rate of fire of 3 rounds in 15 seconds. The high rate of fire can be achieved using the onboard ammunition supply or from ground-piled ammunition. The loading cycle is operated by 2 turret crewmen only, with the commander operating the computer and charge loader. The automatic loader has 5 main subsystems: projectile storage system, projectile transfer system, loading tray with flick rammer, charge loading tray and elevator for external charge supply, and projectile elevator for reloading the external storage or directly loading the gun. The internal projectile storage contains 60 projectiles ready for automatic loading with the remaining 15 stored in other locations. The system enables the handling of all kinds of projectiles in use without any adaptation. Charge loading is accomplished manually using a loading tray with the ignition primer being inserted automatically. All systems have a manual backup so that, in the case of failure, the loading system may be operated partly or completely manually by only 3 crewmen, so allowing a continuous firing rate of 4 rounds /min. The computer also controls the functioning of the gun. The loader control system, LCS, consists of 5 main units. 1. The commander's panel provides the means for the commander to control the automatic loader and has a dedicated keyboard and supporting electronic circuits. 2. The central control unit, CCU, is based on the Intel 80286 and produces all of the system's logic equations. The unit transfers commands through the serial communications, RS-422, to the computerized units and controls the display on the commander's panel. 3. The terminal units, TUs, are based on the 8031 controller for purposes of independent control of the drive elements according to a functionally determined division. With the assistance of the terminal unit, a local mode can also be used in working with selected elements. 4. For guiding operators and making round identification and fusing, the operator's panel, OP, includes a liquid crystal display with fixed instructions and one dot matrix line. 5. The loader keyboard panel, LKP, includes breech block closing switch, fire and local activation of the trays. The main operational roles are firing from internal storage, firing for elevator ground piled ammunition, loading from elevator external pile, synthesizing fire programs, unloading, manual firing, identification, and fusing and checks. Standard equipment includes an NBC system of the overpressure type and an inertial navigation and aiming system designed for autonomous operations. According to Saltum Systems, the 155mm /52 caliber ordnance and automatic loader, or parts of the system, could be installed in other self-propelled artillery systems and used to upgrade other self-propelled systems such as the US-designed and built 155mm M109 and M44. Successor, Carmel, edit. On the 14th of July, 2011, the Jerusalem Post reported that the IDF had begun developing a successor for the Merkava series of tanks. The development was begun in part by the arrival of the Trophy Active Protection System. With the system's ability to intercept threats at a standoff distance, there was a review of the need for vehicles like the Merkava to have thick, heavy layers of armor. The Merkava Tank Planning Directorate set up a team to study principles for a future tank and present ideas for an armored fighting vehicle to provide mobile firepower on a future battlefield. The team reviewed basic design principles including lessening its weight, armor thickness compared to an APS to intercept anti-tank threats, reducing the crew size, and the type of main gun. Horsepower abilities and heavy and light track systems compared to a wheeled chassis were also considered. With future battlefield condition developments affecting design features, the vehicle may not be considered a tank in the traditional sense. By July 2012, details began to emerge of considerations for developing technologies for the new design. One possibility is the replacement of the traditional main gun with a laser cannon or an electromagnetic cannon. Other improvements could include a hybrid electric engine and a reduced crew of 2. The goals of the new tank are to make it faster, better protected, more interoperable and lethal than the prior Merkava. The 65-ton Merkava is not regarded as useful for missions other than conventional warfare. The Israeli Army Armored Corps wants a lighter and highly mobile vehicle for rapid response and urban warfare situations that can fill multiple roles. In 2012, the Defense Ministry drafted a program for development of a new family of light armored vehicles called Rekia, Heavens, a Hebrew acronym for Future Manned Combat Vehicle, FMCV. The FMCV is planned to weigh 35 tons and have sufficient armor and weapons for both urban and conventional military operations. Instead of one multi-mission chassis, separate vehicles in distinct variants will perform different roles with all vehicles using common components. Vehicles are likely to be wheeled to maneuver in urban environments and move troops and equipment around in built-up areas. While the FMCV will be a fifth-generation vehicle as a follow-on to the Merkava 4, it will not be a replacement for the tank. The Merkava and Namer heavy-tracked vehicles will remain in service for decades, while FMCV vehicles are to address entirely different operational requirements. Although the program seems similar to the American Future Combat Systems effort, which failed to produce a family of rapidly deployable lightweight ground vehicles, program officials say they learned from the American experience and that the FMCV was more focused and driven by simpler and more reasonable requirements based on cost considerations. Officials expect requirements for a range of configurations for FMCV light armored vehicles to be approved in 2014 and solicited to Israeli and American companies. The IDF hoped the FMCV family of vehicles would be operational by 2020. The program was named Carmel around 2016, and three contractors, Elbit, Rafael and Israel Aerospace Industries, IAI, were to produce 3 prototypes by 2019. On the 4th of August 2019, all 3 prototypes were tested. IAI's model was based on the company's existing unmanned, autonomous drone platforms, operated by a controller from the Xbox video game system. The tank had a large panoramic display, was able to assist the crew members in identifying targets and selecting weapons, and could drive itself in some terrains. Elbit's model used its Iron Vision helmets, which works with cameras and sensors on the outside of the tank to give the soldiers inside a 360-degree field of vision. It is a variation on a similar helmet that the company created for the F-35 fighter jet. A number of other autonomous and AI systems also assist the soldiers inside in identifying targets and general decision-making. Rafael's prototype used a transparent cockpit design that also gave the 2 soldiers inside a 360-degree field of view. Its augmented reality systems allowed the crew members to quickly see targets, friendly forces and important locations. The Rafael tank also had an autonomous mission support system, for autonomous mission planning, driving, and simultaneous operation of all vehicle weapon systems, all based on combat artificial intelligence capabilities. In 2021, Israel Aerospace Industries, IAI, was selected to lead the next phase of Carmel's development. Export, edit. In May 2012, Israel offered procurement of Merkava 4 tanks to the Colombian Army. The sale would include 25 40 tanks at an approximate cost of $4.5 million each, and several Neymar APCs. With the threat of the expanding Venezuelan military, it would strengthen Colombian armored forces against Venezuelan T-72 tanks. In 2014, Israel reported that exports of the Mk4 had begun. The purchasing country's name was not disclosed for security reasons. In July 2022, an armored vehicle launched bridge, AVLB, variant of the Merkava was delivered to the Philippine Army as part of a government-to-government deal with Israel. Operators, edit. Current operators, edit. Israel. 1 Israeli Ground Forces. Philippines. 1 Philippine Army, Merkava AVLB Armored Vehicle Launcher Bridge. Potential operators, edit. 1 Cyprus, discussing the purchase of Merkava Mark III. References, edit.